Let's talk about systems of equations word problems. I'm going to show you a few different types of examples. Similar problems are on your applications of systems of equations homework assignment, which will be due Sunday at midnight. Okay, so for our first one, the sum of two numbers is 55. The larger number is 17 more than the smaller number. What are the numbers? So first of all, if you're thinking, I would just guess and check, that's fine, but I want you to be able to do it mathematically with equations as well. So first, let's define our variables. Let's say x is our smaller number, and y is our larger number. We know that the two numbers added together is 55, so x plus y equals 55. And we know the larger number is 17 more than the smaller number, so our larger number y is 17 more than the smaller number, so x plus 17. And there's our system. Since we already have y isolated, I would use substitution. So I would take our x plus y equals 55, and instead of y, put in x plus 17. And then what we have is x plus 17 equals 55, or 2x plus 17 equals 55. If you subtract 17 from both sides, we end up with 2x equals 38, divide by 2, so x equals 19. And we already know that y is x plus 17, so then y is going to be 19 plus 17, which is 36. So our smaller number is 19, and our larger number is 36. And just to kind of check, yes, 36 plus 19 is 55, and 36 is 17 more than 19. For our next application, let's say a motorboat travels 385 kilometers in 7 hours going upstream. And 594 kilometers in 6 hours going downstream. What is the rate of the boat in still water? And what is the rate of the current? Okay, my hand's tired. Maybe yours is too. But you can always pause the video if you need to write it slower or keep writing. We have a couple things going on here. First, it's remembering that distance is equal to rate times time. And the reason this works, or one way to kind of show that this works, is if our distance is in kilometers, that's going to equal our rate in kilometers per hour times our time in hours. So then those hours would cancel, leaving us with kilometers as units. Usually we write this as D equals RT because we're slightly lazy. Let's define our variables. Let's say RB is the rate of the boat in still water, meaning there's no current. And RC is the rate of the current, or the speed of the current. So when you are going upstream, you are fighting against the current. It's kind of like running into the wind. So you are slower and cover less distance. So what we know is that you travel 385 kilometers in 7 hours. So our distance is going to be, we're going to have 2 rate times times to combine. So we have the rate of the boat in still water times our 7 hours. And then the rate of the current slows us down. So it's going to subtract from this distance, because again, this right here is distance equals rate times time, and then we're going to subtract the rate of the current times 7 hours, which is another distance equals rate times time, okay? So that's upstream. When you go downstream, you are with the current. So you are faster, it's like running with the wind, and cover more distance. So in this case, the current will add to your distance. So we know that we cover 594 kilometers, and you do the rate of the boat times 6 hours. This is just going back to the problem, 6 hours, 594 kilometers going downstream. And then we add, so this is our distance equals rate times time. This is our distance the boat covers. And we add the distance that the current helps with. So the rate of the current times 6 hours. That's another D equals RT. Now we can simplify the way these look a little bit, and we have our system. So we know that 7 times the rate of the boat minus 7 times the rate of the current equals 385, just changing the order a little bit. And 6 times the rate of the boat plus 6 times the rate of the current equals 594. And there's our system. Let's solve it by elimination. So to make the numbers match, so to speak, if we multiply the top equation by 6, and the bottom equation by 7, we have 42 times the rate of the boat minus 42 times the rate of the current equals 385 times 6, which is 2,310. And then we have, for the second equation, we have 42 times the rate of the boat plus 42 times the rate of the current equals 594 times 7, which is 4,158. Let's add these together, and when we do that, we have 84 times the rate of the boat, the rate of the currents cancel. 2,310 plus 4,158 equals 6,468. Divide by 84. And we know the rate of our boat is 77 kilometers per hour. And now we can use either of our initial equations to solve for the rate of the current. I'm going to use the bottom one just because. So I'm going to use 6 times the rate of the boat plus 6 times the rate of the current equals 594. And we know the rate of the boat is 77. So 6 times 77 plus 6 times the rate of the current equals 594. 6 times 77 is 462, plus 6 times the rate of the current equals 594. Subtract 462 from both sides. 6 times the rate of the current equals 132. Divide by 6. The rate of the current equals 22 kilometers per hour. And we're done with that one. Our final example is similar to number 3, but now we're talking about an airplane. So flying against the wind, an airplane travels 2,580 kilometers in 3 hours. Flying with the wind, the same plane, that's relevant if it's a bigger or smaller plane, it's different data, right? Travels 11,520 kilometers in 9 hours. We want to find the rate of the plane in still air. I'm going to call this RP for rate of the plane, and the rate of the wind, and I'm going to call that RW, rate of the wind. Pause the video for a moment and see if you can set up your equations. Okay, so remember, I'm assuming you paused it and now you're back, or maybe you just want to see it, and that's cool too. Remember, distance equals rate times time. So we know that 2,580 kilometers was covered over 3 hours. So we have the rate of the plane times 3 hours, and that was flying against the wind, so the wind is hurting you or making you travel less distance, so we're going to subtract rate of the wind times 3. And 11,520 kilometers were covered so we have the rate of the plane, and this was in 9 hours times 9, and this was flying with the wind, so the wind helped and added to your distance. So the rate of the wind times 9. And to rewrite a little bit, our system is 3RP minus 3RW equals 2,580, and 9RP, rate of the plane, plus 9RW equals 11,520. You can solve this with elimination. Like we did on the prior problem, I would probably just multiply the top equation by 9 and go from there. And your answer should end up being rate of the plane equals 1,070 kilometers per hour, and the rate of the wind equals 210 kilometers per hour. I would recommend solving that system and making sure you get to these answers.